I'm Colin Johnson. I'm a DevOps engineer and occasional programmer. I helped build out Lyft's infrastructure. Actually, Aaron also worked with me at Lyft, so he's seen some of the work that I did. And he knows that Lyft stays running on Friday nights, stays running through New Year's, and auto scaling is one of the reasons that that was possible. Lyft's traffic is very spiky, so like Friday night at Lyft, you see tons and tons of requests coming in. So it's very valuable to be able to scale up servers on Friday night, and then Monday at like 2 p.m., you probably need fewer servers because you're getting a lot fewer requests. So that really helps contain Lyft spend. I also worked before that at a multi-region ad network. There we utilized auto scaling in order to account for like improved performance. It helped reduce costs a little bit. We've got some folks here from NetShelter who worked with me as well. So they can attest to auto scaling worked pretty well. We had pretty high availability there. I'm an Amazon certified architect, and I was a little late to the game on that. I have a higher number there. But then I was one of the first people to take the SysOps certification exam. I would say if you guys are interested in getting Amazon certified, take the SysOps exam before like everyone else in the world does, and then you can still say like you're one of the first people to get certification. The other thing that I have worked on is I contributed VPC support to Salt. So if you guys are Salt users, do we have any Salt configuration management users here? No? How about Puppet, Ansible? Okay, yeah, we've got some Ansible folks. Okay. If you did use Salt, and it doesn't look like there are folks, and you use Salt to provision VPCs, that's actually some of the work I've done. The objectives for today is we want to understand use cases for auto scaling. When would you use it? When would you not use it? We want to understand the benefits and drawbacks or challenges of auto scaling. And we also want to determine if auto scaling, or be able to determine if auto scaling is a fit for your infrastructure. There may be some instances where auto scaling is not the right solution for you. And then the last thing we want to do here today is, well, go back to your office and implement auto scaling. So the first thing we should do, get out of the way here, is a quick introduction to Amazon. The only reason this slide is here is because we should be familiar with availability zones, because auto scaling helps you spread instances across availability zones. So the first thing to know about Amazon is that Amazon is comprised of regions. There's 9 of them right now. Costs are different, so like US West 2 is the lowest cost region right now. The more important thing to note here is the availability zones. For every region, you have a minimum of 3 availability zones, and in some cases up to 5. Amazon guarantees that your 2A and 2B availability zone are going to have like redundant power, redundant internet, etc. So if you were to lose 2A, then 2B will remain running. So if you're building on Amazon, what you want to do is you want to provision resources in both availability zones. That way you could lose an availability zone. Now folks who aren't using auto scaling have an interesting problem. If they're not using auto scaling and they lose 2A, and they still have one machine running in 2B, their capacity is still halved. With auto scaling, what will happen is Amazon will automatically rebalance your nodes so that if you lose an availability zone like that, Amazon will go ahead and double the capacity in US West 2B. That way you don't have decreased capacity. Amazon launched 2006, so quite a while ago, and in May 2009, auto scaling was released. So this is 6 years old. It's pretty mature technology. Who uses auto scaling in this room? We've got 1, 2, 3, 4, like maybe 8 people. So I would say less than probably 15 or 20% of the folks here. So this is very mature technology, something, if your app supports it, it's something that's fairly easy to implement as well. And it's one of the best features of Amazon. Also to note down here, it took them 5 years to add Amazon's auto scaling to the AWS console. So up until December 2013, you were doing everything command line. So benefits from auto scaling, you're going to get elasticity and scalability from auto scaling. You'll be able to scale up to meet demand. You'll also be able to reduce capacity and reduce cost when demand decreases. So this is pretty valuable stuff, particularly if you have kind of spiky load. So the other cool thing about auto scaling is auto scaling will provide or ensure high availability because it will make sure that you always have a particular number of nodes running. Whereas like with EC2, you launch an instance, the instance fails. You can now bring the instance back, but this is a little bit easier to do. And this also ensures that you have consistent capacity. So if you tell auto scaling you want 20 nodes, you get 20 servers. The other cool thing here, in terms of cost optimization is basically with auto scaling, you pay for what you need. The big areas where we've seen folks have trouble implementing auto scaling, their monitoring tools don't support it, meaning you've configured Nagios to look for your 5 web servers. Well, with auto scaling, the IP addresses of these machines are going to change as they go in service or come out of service. So that's going to play havoc with Nagios in the configuration. Log file collection and analysis, if you have instances coming in of service and then going out of service, your log files are going to get ripped away from you and you won't be able to do analysis. So tools like Splunk, Sumo Logic, or a lot of folks are doing Elasticsearch, Logstash, and Kibana. Those tools can be used to ship logs off of servers and store those logs so that you can do analysis in the future. The other problem here is sometimes applications just don't work well with auto scaling, meaning they store state on disk. If you're storing something on disk and the instance is just ripped away from you because you're scaling down and need less capacity, that data that's been saved on disk isn't going to be recoverable easily. So this is another challenge folks face. Auto scaling groups have min size, max size, desired capacity, and then they have a health check. The health check will remove unhealthy nodes from a load balancer. So if you have a load balancer sitting in front of 6 instances that are running, say, Apache, if the load balancer says, oh, Apache's not running or it's not serving content at like index.html, the load balancer will remove that instance from service. Optionally, that instance can be terminated and a new instance can actually take its place. So if you have a node that's failed and it's not serving web traffic, you can actually terminate that node, get a new node brought right back into service. Launch configurations dictate how large your instances are, key names, security groups, and then one other interesting thing right here is a spot price. So if you would really like to save money on Amazon, what you can do is you can say, Amazon, I'm only going to buy or rent an instance for the next hour if that instance is below a particular cost. Now the risk here is that Amazon comes back to you and says, sorry, you don't get the machine. So you could bid 2 cents for a machine, and Amazon's going to say, sorry, we don't have any machines available right now for 2 cents. And then what you'll do is you'll bid automatically again and again and again until you get that machine. And then when the cost of that instance goes above the 2 cents you bid, Amazon's going to take that instance away and will not give you additional machines. The other cool thing about auto scaling group, you can automatically tag machines that are in an auto scaling group, so when they come up, you can find them. One of the things about machines coming in and out of service, you're probably not going to want to name them because that machine may be gone in 5 minutes. So what you do is you utilize tags and you can say, okay, these are all my web servers or these are all my API servers, and you can do multiple tags. So if you're looking to do something like cost allocation, you can tag a machine with an owner. You can say like Colin owns that machine, and you can tag the machine with a department, meaning DevOps or front-end developers. And you can also tag with environment, say production. That way when somebody says, hey, how much are we spending on this particular environment, or are we spending on this application, you can later use a tool, either Amazon's Cost Explorer or another tool, to get a list of all of the spend on an application or on an environment basis. Typical design for auto scaling is going to look generally like something for ingress of data, meaning a load balancer or SQS. And it's also going to look like using CloudWatch for controlling scaling. CloudWatch is Amazon's alerting and monitoring tool. And what it will do is it will take metrics from your auto scaling group or from an SQS queue or from a load balancer, and then it can trigger an action on your auto scaling group. So you could say something like, if I get more than 50% CPU utilization on a machine, please scale up another machine into service. Or you could say something like, if there's 100 items in a queue, please scale up another machine or another 2 machines. So this is what that looks like. You'll see a fleet of web nodes right here. We call these guys prod, but these could be anything. And what they're going to do is they're going to take traffic and they're going to take requests, and they're going to send those requests to API-prod 01 ELB. This is Amazon's load balancer. So what's going to happen is the requests are going to come into the load balancer, and the load balancer is going to direct requests at the one API node that is available. If you have a scaling event, what will happen is additional machines will be brought into service and automatically register with the load balancer when they pass a health check. So this way, you can scale from 1 machine to 3 machines and then back down, and you don't need to reconfigure any of the web nodes up top. You can do the same thing with an Amazon SQS queue. Here we have web nodes placing items into an SQS queue. As the SQS queue fills up and you need additional backend capacity for processing items in a queue, we can scale additional nodes into service. What will happen is these nodes can come up and pull items off of the queue and continue to process. You can also use the queue with something like Amazon Spot, where you put items in the queue and then you only scale servers into service after Amazon has accepted your bid. So the other very cool thing about Amazon's auto scaling is it integrates with a number of Amazon's other services. It integrates with CloudFormation very nicely. CloudFormation can create auto scaling groups, can create launch configs, can create user data that allows you to configure machines when they come up. Or do we have Docker users? We got a maybe Docker user and a yes Docker user. Do we have any positive I'm in production Docker users? No cutting edge folks today. All right, auto scaling integrates very nicely with Amazon's code deploy. This ensures that when your machines scale into service, that your code is put on the machines, and it can also allow you to update machines. With code deploy, you can say, look, all my machines that are in this auto scaling group, go ahead and deploy code to these machines. So code deploy and auto scaling integrate very nicely. The other interesting thing here is if you really, really take apart a load balancer, you might discover that load balancers actually seem to be built using Amazon's auto scaling. And you can see that. There's a couple of tricks. If folks are curious about how load balancers are built, at the end of this, just ping me and say, hey, I'm curious about load balancers. I can show you a couple tests to run to figure out how load balancers work and to basically get some more information about those. Elastic Beanstalk is actually comprised of a load balancer or an SQS queue. And so this is Amazon technology. It's comprised of a load balancer, an auto scaling group, and an SQS queue or an Elastic load balancer. So the cool thing about Elastic Beanstalk is you can look at Elastic Beanstalk and figure out what Amazon's best practice architecture is by just copying their platform as a service. It's right there. You spin up Elastic Beanstalk, you can see exactly how Amazon wants you to do things. The last reason I was asking about Docker users, which apparently we have 2 of them, is Amazon has an EC2 container service, which is capable of running Docker containers. So with auto scaling, what you can do is you can have machines come up and add themselves to the EC2 container service cluster so that you have additional capacity to run Docker containers. So this is all handled through auto scaling and user data. We'll go ahead and do a live demo here. And if folks are interested, go ahead and take out your laptops, follow along.